So, kind greetings to you all. I believe that everything is progressing on smoothly. I left some questions for you to work out, and I assume that they were worked out exhaustively. So today we continue with there are two cases. Don't forget that there are two cases of exploration. This is case two. Case two. Case two. This is presence of acid catalyst. Acid catalyst, preferably dilute sulfuric acid. Presence of acid catalyst, preferably dilute sulfuric acid. Now, for this, still we shall start in the same way. We have to get the general intuition, then we look at specific examples. So examples, a general example, RCHO plus RNH2 in presence of hydrogen ions from dilute sulfuric acid. Yeah, so the mechanism here, still we shall start by exposing the functional group, the carbon to oxygen double bond. I expose it very well, like that. That carbon to oxygen double bond is polar because oxygen is more electronegative than carbon. We have seen that exhaustively for the previous lectures. If you are watching this for the first time, I will refer you to those lectures where we have had the chemistry of the carbon to oxygen double bond. So oxygen pulls acquires a partial negative charge, carbon has a partial positive charge, meaning that it is electron deficient. The derivative of ammonia is electron rich because it is made up of a nitrogen atom that has lone pairs of electrons that can be donated to carbon, which is electron deficient. Therefore, we get R, C. This is now a single bond with oxygen. Oxygen has a negative. Why it is having a negative? Because one bond has been broken previously. There were two bonds, so the negative corresponds to electrons which were in one of the broken bonds. This carbon carries hydrogen. Then I am also bonding it with N, which has donated, therefore has a plus. That N carries. Sorry. I think I am still recording the other thing. Sorry. You see how I have been locked up. This is what we have been doing previously. For absence of a catalyst, that's what we are doing. Sorry. So in presence of a catalyst, we start by exposing the functional group. Oxygen has lone pairs of electrons that can be donated to the proton. The proton, which is the hydrogen ion from the sulfuric acid. Now, once we donate to the proton, we shall come up with RC, double bond with oxygen. Oxygen is electron deficient. Why? It was having lone pairs of electrons, which it donated to hydrogen. So therefore, oxygen has a plus. It carries hydrogen. It carries hydrogen. Then carbon also carries hydrogen, like that. That's what we are having. So in this case, we start with protonation. You see, for the things which are rubbed off, we do not start with protonation. The bond is polar, oxygen takes, but here we start by protonating. Oxygen donates to hydrogen. Now, since oxygen has a plus, it is electron deficient. And here in the double bond, we have a center of high electron density. Therefore, we donate electrons to oxygen. Then carbon becomes electron deficient, and our RNH2 is electron rich because they are lone pairs of electrons on nitrogen. So they are donated to carbon. As a result, we shall come up with RCOH. It is now a single bond, and oxygen is not having a negative. Why? That oxygen was having a plus, so I donated electrons to oxygen which was having a plus. If that oxygen was not having a plus, I would have put a negative on that oxygen, but it's not there. Then this carbon carries H. I am bonding it with N that has donated, therefore that N has a plus. That N carries 2 hydrogens and R. So nitrogen is electron deficient. I give it electrons using the hydrogen appending from it, like that. But that is a covalent bond where I'm picking electrons because it is formed when nitrogen contributes electrons and also when hydrogen contributes electrons. Now I'm taking all those electrons and I'm donating them to nitrogen, meaning that that hydrogen is going to become electron deficient. So it has to shift where we have electrons, and where we have electrons is where we have that oxygen. This oxygen here has lone pairs of electrons. So those lone pairs of electrons are donated to that hydrogen. So the hydrogen shifts to that oxygen. At this level, we have a hydrogen shift. Hydrogen shift so that we get RC, oxygen. Now oxygen carries 2 hydrogens because previously it was carrying 1 hydrogen, but 1 has shifted there. So now we come to that oxygen has a plus because it has donated electrons to hydrogen, which shifted to it. Like that. And then it also carries hydrogen and nitrogen with N and R, like that. However, the oxygen up, you see it has a plus, so it is electron deficient. We give it electrons using those in that bond, like that. Now, as we give it electrons using electrons in the carbon to oxygen single bond, carbon becomes electron deficient, but there are lone pairs of electrons of nitrogen here. So they are donated to carbon. As a result, we lose a water molecule and then form R CH. This is now a double bond. N has a plus. N carries hydrogen and R. That. So N is electron deficient. So we give it electrons using the hydrogen appending from it. Therefore, we lose a proton. We lose a proton. Minus hydrogen ion. Then we form RC H. This is a double bond. N R. You see, now what I have, what do I have? I have, so you see, at last a hydrogen ion is lost, meaning that it was working as a catalyst. That's why a catalyst is not utilized. You have to show that it is formed again. So what are my products? I have R, CH, double bond, NR plus H2O. Like that. I take another example so that I continue giving you a clear picture. For that case, I've been using an aldehyde. Now I proceed with a different compound, ketone, reacting with the RNH2 in the presence of hydrogen ion, like that. We start by exposing the double bond. The chemistry does not change. The carbon to oxygen functional group. But this is fine. Sorry. The carbon to oxygen double bond is polar because oxygen is more electronegative than carbon. So oxygen takes electrons. Once it takes electrons, it acquires a partial negative charge. Carbon has a partial positive charge, meaning that it is electron deficient. So since it is electron deficient, I don't know why I'm starting with this. Sorry, I am still recording the other first approach, but forgive me, my mind is a bit stuck. Yeah. Sorry, that was for the that thing which I've been outlining was for the first alternative, absence of a catalyst. Absence of a catalyst. Although we form the same products, the products are the same, but the mechanism differs slightly. Sorry, I am locked up, so this is a different mechanism. So here we start with protonation. The hydrogen ion is electron deficient. You have lone pairs of electrons on oxygen that can be donated to hydrogen, like that. Then we form RC, double bond with oxygen. That oxygen has a plus because it has donated, carries hydrogen, and R prime, like that. Now, since oxygen has a plus, it is electron deficient. Here we have a center of high electron density. There are electrons within this double bond, so we donate to oxygen. As a result, carbon becomes electron deficient. Therefore, we bring our derivative of ammonia, RNH2. It's electron rich because there are lone pairs of electrons on nitrogen that can be donated to carbon. As a result, we obtain RC. Now that C, previously we were having a double bond. This is now a single bond with the OH. And the O is not having a plus. It is not having a plus because we have donated electrons to it. And it's also not having a minus. Yeah. Because O previously was having a plus. Now this carbon also carries R prime. I am bonding it with the N, which has donated, therefore N has a plus. N carries hydrogen and another hydrogen. That N also has R. That. So that's what I have. N has a plus, so it is electron deficient. We give it electrons using the bond which is appending from it. Yeah. We reduce on the excess bonds on it. It is having excess bonds. Yeah. So that's why we have to reduce on those bonds by donating electrons to it. Therefore, since we donate electrons to it, we lose hydrogen. Yeah, because the bond between nitrogen and that hydrogen down, this bond here, it is a covalent bond, meaning that it is formed when nitrogen contributes and also when hydrogen contributes, but I've taken all the electrons and donated them to nitrogen, meaning that hydrogen becomes electron deficient. It has to shift where? To where we have electrons. And I want to claim that this oxygen here has lone pairs of electrons. Those lone pairs of electrons in pink there, that oxygen. So that hydrogen goes to that oxygen where we have electrons. As a result, what we have? We have hydrogen shift. Hydrogen shift resulting in formation of R, C with R prime. This is now oxygen with 2 hydrogens, and oxygen has donated electrons to the hydrogen which has shifted to it, therefore it has a plus. Then with the N, H, R, like that. So the oxygen up has a plus, so I give it electrons, or it has excess bonds, so I reduce them by donating electrons to oxygen using that bond appending from it, from the carbon atom. like that. Now, as I donate electrons, meaning that it means that carbon becomes electron deficient. There are lone pairs of electrons on nitrogen here. They are donated to carbon. As a result, what have I done? I have lost the water molecule. I have lost the water molecule, and I have formed R, C, R prime with a double bond, N as a plus because it has donated, but that N carries hydrogen. It also carries R. So N is electron deficient. I give it electrons using the bond appending from it, like that. So in this case, I lose hydrogen ion, meaning that it was working as a catalyst. That's why it has to be formed again. As I form R, C, double bond, C. Sorry, this is not correct. R, C with R prime. This is a double bond, N, R, like that. So what have I formed? I have formed R, C, R prime up, a double bond with the NR plus H2O. Like that. So now I take specific examples. Those are the general reaction mechanisms. Yeah, this is in the presence of a catalyst. As specific examples, the first one, I consider propanol and hydrazine. The reaction occurs in presence of a catalyst. Hope this time round I'm not going to forget that I have a hydrogen ion. The mechanism differs slightly. That hydrogen ion is not there. I have explored all those cases. So we start by exposing the functional group, the carbon to oxygen double bond, like that. Now, in the presence of a catalyst, the hydrogen ion, in presence of the hydrogen ion, we start by protonating. Oxygen has lone pairs of electrons that can be donated to the electron deficient hydrogen. So we get those electrons and donate them to hydrogen. So what do we form? So in this case, we have CH3, CH2, C, double bond with O. O has donated, therefore has a plus. Now I am also bonding it with hydrogen. Then carbon carries hydrogen like that. So you see that oxygen has a plus. Moreover, oxygen has excess electrons. Yeah, excess bonds. Yeah, it has 3 bonds. These double bonds with carbon and another bond with the hydrogen. So we have to reduce on those bonds by donating electrons to oxygen. Yeah, so it is electron deficient. The oxygen atom is electron deficient. We give it electrons using those in the double bond. Once we give oxygen electrons, now carbon also becomes electron deficient. Why? I am taking electrons from a covalent bond. Covalent bond which was formed when carbon contributed electrons and also when oxygen contributed electrons. Now I have taken those electrons and donated them to oxygen. So carbon is also becoming electron deficient. It needs electrons. And the derivative of ammonia, NH2 is electron rich. There are lone pairs of electrons on nitrogen that can be donated to carbon like that. So if I donate to carbon, what do I form? I form CH3, CH2, then C. This is now a single bond with the OH. Previously, it was a double bond, but I've reduced on those bonds by giving oxygen electrons. Now, this carbon also carries hydrogen. I am also bonding it with N. I am bonding it with N, which has donated, therefore has a plus, carries hydrogen, and another hydrogen, and the NH2, like that. Therefore, I give electrons to nitrogen. Nitrogen is having a plus, so it is electron deficient. It needs electrons. Or it is having excess bonds. So we reduce them, or we give nitrogen electrons using the hydrogen appending from it, that bond appending from it. Now, once we give it electrons, the hydrogen becomes electron deficient. It has to shift to where we have electrons. I want to claim that this oxygen up here is electron rich. There are lone pairs of electrons on it. Therefore, hydrogen has to go to that atom that has electrons. In this case, it is that. So what do we have? So it goes there up so that we form, so that we have, I don't know, maybe I continue here. We have a hydrogen shift. A hydrogen shift that results in formation of CH3, CH2, C, H with the OH2, O has a plus. It has donated electrons to, oxygen has donated electrons to the hydrogen, which has shifted to it. That's why it's having a plus. Then with the NH2, like that. Therefore, oxygen is having a plus. It is electron deficient, or it is having excess bond. So I give it electrons using electrons in this bond, like that. So if I give it electrons, carbon becomes electron deficient because I am taking electrons from a covalent bond which was formed when carbon contributes and oxygen contributes. Now I have taken all those electrons between the two atoms of which carbon contributed and I've donated them to oxygen. Therefore, carbon becomes electron deficient. Now, once carbon becomes electron deficient, there are lone pairs of electrons on nitrogen that can be donated to that carbon. As a result, what has happened? I have lost, I hope this space will be enough. I have lost a water molecule, minus H2O, as I form CH3, CH2, CH, double bond with the nitrogen, which has a plus because it has donated, NH2, that nitrogen also carries a hydrogen, like that. Now, nitrogen is electron deficient. I give it electrons using that hydrogen appending. Therefore, I lose a proton minus hydrogen ion as I form CH3, CH2, CH, double bond with NH2, like that. Hope you still remember the name of that compound. We named these compounds before. If you are watching this video for the first time, I will refer you to the previous videos. This is known as propanal hydrazone. Propanal hydrazone. So what do we have here? I have formed the mukama wange sebo gyebaleko kale sebo nedda tekirina buzibu. Kituufu baategese naye dates za njawulo. Balina okuba nga batandise butandisi. Sisuubira nti oba abaddeyo ne semina bulijjo. Batandika butandisi bwe kirina okuba. Nabbi ng'etegese, Nabbingo naye etera kukola A-level. Naye bano bakoze O-level yokka. Era mukama wange mbadde simanyi, mbadde noonya lisiti eno. Lisiti eyo kuba nze okyagiina kale wabakubidde We continue. We continue with another example. So here I've been considering proper null. Now I take the one which you shouldn't forget. Hope you still remember the one which you shouldn't forget. I have mentioned that thing severally. I don't want to repeat it again. Hope you still remember the one which you shouldn't forget. Let me use it here. I use methanol and our dangerous Brady's reagent. The one which you shouldn't forget. Colleagues, don't forget this thing. Now there is something which is playing on my screen here. That's gone. There is another one here. With the hydrogen ions. Like that. So methanol has this representation. There are lone pairs of electrons on oxygen that can be donated to the hydrogen ion. Here, in the presence of the hydrogen ion, we start with the protonation. So now hydrogen goes to that oxygen. So we have HC double bond with oxygen. Oxygen has a plus because it has donated, carries hydrogen, like that. Oxygen is having a plus and it is having excess bonds and it is electron deficient. Therefore, we give it electrons using those in a double bond. So carbon becomes now electron deficient. Therefore, I bring my Brady's reagent, the one which you shouldn't forget. Hope you know the reason as to why you shouldn't forget this versatile compound. I mentioned those reasons. There are lone pairs of electrons on that nitrogen. However, don't forget that there are also lone pairs of electrons on this nitrogen. And I don't use it. If you use it, you form a wrong product. For the reasons which I have explained exhaustively. If you are watching this video for the first time, kindly refer to the previous videos. Those electrons, we don't use them on that nitrogen. We don't use them. They are not there. You may think that they are there, but previously I've explained that they are not there. So we use the ones here and donate to carbon. So we have HCOH, that is now a single bond. a single bond with oxygen. Yeah, because the double bond was broken. That carbon carries hydrogen. I am also bonding it with nitrogen. Nitrogen that has donated therefore has a plus, and it carries hydrogen. Also another hydrogen. It also carries N and H. Yeah. Like that. That's what we have. Then what? The nitrogen has a plus, so it is electron deficient. I give it electrons using the hydrogen appending from it. And once I give nitrogen electrons, the hydrogen also becomes electron deficient. So it has to shift to that oxygen up, because that oxygen up is where we have electrons. So in this case, we have hydrogen shift. So resulting in formation of H, C, H. Now this C with O and the 2. I don't know. Okay, I continue. This O has a plus because it has donated. C carries N, which N has H, N, H. Okay, that. So oxygen is electron deficient. Moreover, it has excess bonds, so we give it electrons. Then carbon as well becomes electron deficient. There are lone pairs of electrons on nitrogen that can be donated to that carbon. So what have we done? We have lost a water molecule minus H2O as we form C, H. This is now a double bond with N that has a plus. That N carries another N and H. Like that. So with the NO2, NO2. Then the N here has a hydrogen. Yeah. So the N has a plus. It is electron deficient. So we give it electrons using those in the bond appending from it. That bond of hydrogen, like that. Then hydrogen is lost. Hydrogen is lost. Minus hydrogen ion as I form H. This is a double bond. N, N, H. Like that. Hope you still remember the name of this compound. So that is what I form. I'm running out of time. How many minutes I have? Do I have? I have 4 minutes left. So that is done. Don't forget to complete the equation. You people, you are so forgetful. Don't forget that you have to complete the equation. plus H2O, like that. So that reagent is very important. Note that Brady's reagent are also known as 2,4-dinitrophenyl hydrazine is used to confirm for the presence of carbonyl functional group within organic compounds. That's why I was saying that you shouldn't forget it. It is used to confirm for the presence of carbonyl functional group within organic compounds. It's used to confirm for the presence of carbonyl functional group within organic compounds. So the observations with on treatment of both aldehydes and ketones, with 2,4-dinitrophenyl hydrazine, on treatment of both aldehydes and ketones with 2,4-dinitrophenyl hydrazine, a yellow or orange precipitate, depending on your chemical eye. Depending on your chemical eye, you can observe a yellow or orange precipitate is observed. Then with other compounds without carbonyl functional group,